And we are live, you guys. Hey, it is April 30th, so it's Landon's birthday. So if you guys see him, or, well, I don't know if you'll see him, but you can always text him. Landon's birthday. Yay, Landon. He's 17 today. So give him a text, give him a high five, whatever, and say, hey, happy birthday, Landon. So, what am I going to do? Today is pretty easy. I like this geometry stuff because, you already know this. We're going to talk about rhombi. That's more than one rhombus, and squares. So a square is a rhombus. We'll talk about that. So first, let's look at homework answers from yesterday. So these are the answers that I have. Number one, it's not enough information. We know these are parallel. If we knew they're the exact same size, if we could say that side is equal to that side, we say yes, but they didn't tell us that. All we know is parallel sides. So it could be drawn in a lot of ways. That's all we know, okay? Number two, yes, those opposite angles are equal. 3, yes, diagonals bisect each other. 4, when you solve for x, you get 40, and then you plug the 40 back in, and then 40 here makes that 80, and these two have to add up to 180, so then you end up getting y to be 25, or you can set these two equal, either way. 5, diagonals they bisect each other, so I get x equals 5 and y equals 1. 6, y is obviously 160 opposite angles. Whoops, can't see anything. Y obviously 106. X, set these equal to and solve, and you get x equals 8. 7, you set these equal to each other and you get x equals 17. And believe it or not, you set these two equal to each other and you get y equals 17. And that will prove they are parallelograms. Okay, so that is yesterday's homework. Now, what about today? Well, today is actually pretty darn easy. I think you're going to find today not too bad. So what were we talking about? Objective. It is 4:30. 2020. Okay, so we're going to talk about rhombi, rhombi, and squares. All right, so rhombus. Let me draw a picture of a rhombus and a square. So I get my little template thing out here, which is pretty darn cool. And if I look at this, that looks like a square. Okay, but that is not what I'm looking for, because a rhombus basically has, well, it's a quadrilateral first, a quadrilateral that has four congruent sides. Okay, congruent, same thing as equal, kind of sort of. Okay, so if it's quadrilateral, 4 congruent sides, if you take a look at my little template here, that is indeed a rhombus, but it's more specifically a square. So the one I'm looking for looks like, and it's on here because I saw it this morning. I was going to show you. Where is it? It is on here. Oh yeah, you guys are probably like, it's right there, it's right there. Okay, so let's take a look at this one specifically. Okay, what I like about this one here, it looks like a parallelogram, and sure enough, it is a parallelogram. So what we know about a rhombus is 4 equal sides. Okay, so that side is equal to that side, is equal to that side, is equal to that side. Okay, but the thing about a rhombus is also a parallelogram. It's just a special parallelogram, okay? It is a parallelogram, so opposite sides are going to be parallel, right? Opposite sides are going to be parallel. So if I do my A, B, C, D right off the bat, what I know for sure is that all sides are equal, and I know it's a parallelogram, so I know that AB is parallel to DC, and I also know that AB is parallel to, I'm saying the same thing, BC is parallel to AD. There we go. All right, it is a parallelogram. So if it's a parallelogram, everything that we know about it is true. Opposite sides are equal, opposite angles are equal. Okay, I mean really it's the same thing. Opposite angles are equal, opposite sides are equal. We know that diagonals bisect each other. Okay, that is also true in a rhombus. but there's something more and unique about a rhombus that we're going to talk about. Okay, what are the special characteristics of a rhombus? Okay, so if you look at our journal, okay, if we go to our journal, they do a really nice job of showing. Okay, so if I got my rhombus, this is 7-4. I want to show you. If you go to your rhombus, okay, they show us some special things about it. Okay, so here's one thing that's unique. Okay, they show the parallel sides. Okay, because it is a parallelogram, but they show this, that the diagonals cross in 90 degrees. So the diagonals are not only bisect each other, not only do the diagonals cut each other in half, the diagonals are perpendicular. So I'm going to write that down in my special characteristics. The diagonals are perpendicular. Perpendicular. Like 90 degrees, right? Okay, that makes sense. So that's one of the special characteristics of a rhombus, is that 90 degrees. There we go. What else do we have? Okay, so we look at here. So opposite angles are equal. I agree with that. But they look at this picture. It shows me like this angle is equal to that angle is equal to that angle, and that angle is equal to that angle. So the diagonals bisect the angles. Okay. So second thing we have is the diagonals bisect the angles. Okay, what does that mean? Well, it means like this. It means that this angle right here is equal to this angle here. This angle here is equal to that angle here. This angle is equal to that angle, and this angle here is equal to that angle. So those angles are equal, okay? Because it bisects, okay? Well, is there anything else special about it? Well, let's take a look. Okay, there's a few things in here. Okay, now, that's about all we get, except for then they talk about a rectangle. Okay, so now a rectangle is different, okay? So that's a rhombus. Now, what do we know about a rectangle? Well, a rectangle really is a parallelogram. It's really, and I can draw a picture too with my little template. First, let's go ahead and write down the definition. It's a parallelogram with 4 right angles. Okay, we know that. So if I take a look at my rectangle, yeah, it looks like a rectangle right there. Okay, my little templates. There it is. So it is a parallelogram, so everything we know about a parallelogram is correct. That side's parallel to that side, yes. We know that side is parallel to that side, yes, we know all that. We know that diagonals bisect each other, and then what we also know is 90 degrees. We know this. See, this is where geometry is so easy, you guys. But what makes a rectangle even more special is the fact that the diagonals are actually equal. So if anybody has a dad, or maybe a mom, who does construction, contractor, this is how they can tell if a building is square. And if your dad's a contractor, you can talk to him about it, but they'll plot a rectangle and then they'll measure here and they'll measure here. If the length of this is equal to this in a plot, out in a field, or on a, you're going to build a building, you need a rectangle. If this length, the diagonals are equal, you know it's square, okay? Alright, so, what's special about it? Diagonals are congruent or equal, right? Okay, if I look at my book to see if there's anything else extra, I don't believe so. I think that's about all we get for a diagonal. And, of course, everything else in it is true. Everything else. We know that opposite sides are, because it's a parallelogram, opposite sides are parallel, opposite sides are equal. Diagonals bisect each other because it's a parallelogram, so I do know that's equal to that. And then that's equal to that, not only that, but then the diagonals are also equal to each other, okay? So everything we know about a parallelogram is true. Now, a square. There's 2 ways to describe a square. Okay, one, it could either be a rectangle with 4 equal sides, or you could describe it as a rhombus with 4 right angles. But either way, a square, I like to say, is a rhombus with 4 right angles, okay? So let me find my little square in here. And it is right, oh, there's all these things here, right there. There's my square. Okay, and of course if it's a rhombus, then it's also a parallelogram, isn't it? And therefore everything else is like opposite sides are parallel, opposite sides are equal. It's a rhombus, so all 4 sides are equal. The diagonals are going to be, let me draw in the diagonals so you guys can see my diagonals. The diagonals are congruent and they bisect each other at 90 degrees, okay? There it is. There's square. So we know the diagonals are congruent, diagonals bisect each other, and at 90 degrees. Of course, all 4 sides are equal. Okay, that's a square. That's pretty easy. Okay, now let's take a look at some things you may or may not know, because that seems pretty easy, doesn't it? Okay, so moving on. All right, so here we go. Let's do some examples. Okay, number 1, find all the missing angles and lengths of this rhombus. Now, this thing sure looks like a square, but it's off by a little bit. And I know it's off by a little bit because that's 42 degrees. That'd be 45 if it was a square, okay? So let's see what I know. If that's 9, that's a rhombus, right? If that's 9, this side's 9. It's a rhombus, right? So that means this side's 9 and this side's also 9, right? Diagonals bisect each other, so if this diagonal 7, this diagonal 7 here. We don't know anything about these diagonals, so we need more information, but that's okay. We do know that it's 90 degrees here, so we could use Pythagorean's theorem to get this. We could. If we needed to get this side here, call that, say, b. We could go 7 squared plus b squared equals 9 squared, right? And so I'll have b squared equals 9 squared minus 7 squared. Now we just use my calculator to get that. Watch this, huh? I'd go 9 squared, subtract 7 squared, and I get an answer of 32. So then I take the square root of 32, and I get an answer of about 5.66, or the square root of 32. And we can reduce that to 4 square roots of 2, okay? And that's those sides. Now, 42, check it out. I know a couple of things. Let me get a different colored pencil. Here we go. If this is 42, this is 42, okay? I know that if that's the case, 42, 42, they bisect each other, so this is going to be 42, this is going to be 42, right? If I need this angle from 90, these two have to add up to 90. I can go 90, no, I'm sorry, 180. I go 180 minus my 84. Use my calculator. 180 minus 84. I get an answer of 96, but I divide that in 2. And so I get 48. So this whole angle is going to have to be 48, 48, right? Okay, 48, 48. 48, right? 48, and then 48, and then 48. Got it. Okay, now, easy. Moving on, example 2, draw a rectangle. Okay, so I'm going to draw a rectangle. Get my little template out. Draw a rectangle. Here we go. And what do I know? So the diagonals. All right, so I'm going to put a diagonal in. I like using different colors. Helps me a lot. Diagonal. Here is another diagonal. Okay. And then, what do we have? Okay, I've got AC and BD, right? So AC, and then since it's a rectangle, right, we know that diagonals are equal. So I know that AC is congruent to BD. I know that. These two sides are equal. So therefore I can say that 2x minus 6 is equal to 3/2 x plus 1. Oh, I love fractions. Don't you guys love fractions? So how do I do this? Well, this isn't too bad. Let's see. That's the same thing as a 1 and 1/2, right? 1.5. So I'm going to go minus 1.5x. I'll cancel that. Minus 1.5x. 2 minus 1.5 is half, or 0.5x. Minus 6 equals 1. Plus 6 plus 6, 0.5x equals 7. Divide by 0.5, and x is 14. There we go. So if I want the length, just take my 14. Let's plug that into the easy one. Right into there, okay? Plug it into that one. So I know that AC is going to equal 2 times 14 minus 6. 28 minus 6 is 22, right? So I go my 2 times 14 minus 6, and I get 22. Yeah. So AC is 22, and then obviously BD is also 22 because they're equal. That's bad looking too, sorry you guys. 22, there you go. Okay, not too bad. Okay, example 3. Now I got to prove it, okay? So let's see. What is it? Well, let's go ahead and go through it. -4, -1, A. -1, 5. B. 1, 2, 3, 4, 5. 2. There's C. 1, 2, 3, 4, 5. Whoop, I went too far. 1, 2, 1, 2, 3, 4, and there's D. You know, it looks like it might be a square, it might be a rectangle, but let's double check some things, okay? So first of all, first thing I'm going to do is check for slopes, okay? Because if the slopes aren't the same, then it's none of the above. So that's the first thing I'm going to do is check for slopes, okay? I want to see what it is. Sure looks like it might be a square. Most specific. But first, let me check slopes, okay? So slopes. Let's check AB. Up. 1, 2, 3, 4, 5, 6. 1, 2, 3. So the slope is up 6 over 3, or 2 over 1 is my slope, okay? Up 1, 2, 3, 4, 5, 6. 1, 2, 3. Up 6 over 3 is 2 over 1, okay? Alright, these are parallel for sure. Down 1, 2, 3, 1, 2, 3, 4, 5, 6. Down 3 over 6, -1/2. Oh, that tells me these are perpendicular. I like that because opposite slopes, 90 degrees. Same thing here, down 1, 2, 3, 1, 2, 3, 4, 5, 6. Hey, that's down 3 over 6, which is a -1/2. Tells me that's perpendicular. Okay, so here's what I know. Okay, I know for sure it's a rectangle. Now, what about lengths? Well, if I want to find out the lengths, I'm pretty sure it's a square, but I just said the 3, 6. So if I take a look, and I only need to do one of these, because they're all the same triangle, right? And if I want to find the length of one of these sides, I can just use Pythagoras' theorem. In fact, that same triangle is all over the place, right? See the same triangle? See the same triangle if I use Pythagoras' theorem? Okay, so I want to find this length here, okay? Here's what I'm doing. See this length? This length can be found by Pythagoras' theorem. A squared plus B squared equals C squared. So if I want to find the length of AD, I would do A squared plus B squared equals C squared. I go 3, 1, 2, 3, plus 1, 2, 3, 4, 5, 6 equals C squared, which is AD. 3 squared is 9, not 6. 6 squared is 36, equals C squared. I get 45. Square root of 45. Now, I know the other two are going to be the same thing because I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, the exact same formula. 1, 2, 3, 4, 5, 6. 1, 2, 3, same exact formula. 1, 2, 3, 1, 2, 3, 4, 5, 6, same formula. So here's what I know. Parallel. Opposite sides are equal, 9 degrees. This is specifically a square. All right, how's that? There you go. So homework today is going to be on page 242. Okay, let's go check it out. 242. This is easy stuff. Everybody should be doing fine on this. 242. And I'd like you to do the 1 through 11 all. Page 242, 1 through 11 all. Here it is. Page 242, 1 through 11 all. Okay. I look forward to seeing what you guys have. Have a great day. Happy birthday, Landon.